always like, I just blank out and I just like go to sleep, I eat, I get distracted, game. The next thing I know, I'm not like doing whatever it is I'm supposed to do. But I mean, I have my ways to like get that stuff done. Ooh. All right. This okay. Looks good. Let's check here one more again. Done. Let me get this student. Is that right? That is correct. Let him in. Okay, that looks good. And let me share my screen up. That's not it. Interesting. Okay. Cool. I didn't know I could do that. All right, let me share my screen. Start the broadcast. So looking pretty good today. I'm only missing one scholar, right? Okay. This is what, at 3 p.m. Okay. Let's go to view, single page. Okay. All right, scholars. So let's see. So welcome. Hopefully everyone had a great weekend. I wish I could leave it like that. Let's see. As far as announcements, so the main thing, let me see. So we had exam 1 that was due Sunday night at 11:59 p.m. On any of your assignments on Pearson, if you have below a 90%, you can always, I would encourage you to go back and redo them to improve your score. If you are doing like redoing old assignments to improve your score, I would encourage you to prioritize your exams, as that's where you're going to get the most bang for your buck, right? You are welcome to go back and do like quizzes and homework to improve your score, but then that's going to be like a lot of work for little points, that most of your weight comes from the exams. As usual, if you have questions about anything or if anything is not clear, feel free to either unmute yourself to get my attention and we can talk about it, or type it in the chat. Let's see. Yeah.
Take the test.
Yeah, I think so. Yes. If you made below a 90, then you can do it again. Because yeah, it's only a 10% late penalty. So on all assignment. Yep. Trying to think if there's anything else. Oh, another thing. So I know I just got off the phone with my supervisor. I know that some people's temporary trial is running out. So the conclusion that we came to was that he said that you all should be able to continue to get a free trial until this matter is resolved, right? So I asked him, well, does that potentially mean that the longer it takes for them to settle this thing, the students potentially could gain access to the materials for free for the semester? And I think his response was, you all should be able to continue the free trial until the matter is resolved, or as far as the discounted price, because this is something that was supposed to be resolved before the semester started, and it just wasn't. I think he was saying that like one of the administrators from the bookstore retired. We had like a couple of administrators retire. So then when you have a change in administration, then that creates like all these like hiccups and things. So I had one student in the last class. He already had the material, but he was trying to wait it out, because if you get it discounted, he might be able to like do a maneuver or whatever. But I think I encouraged him to purchase it. But then I had this conversation after speaking with him, and the conclusion was you should be able to continue getting temporary trials until they offer the discounted price. So again, right now, just essentially wait for the trial to run out and then try to start it again. Because if you have a second one going now, you should be able to do a third one again until they offer the discounted price. So you potentially could get the semester for free using my math lab, which is actually huge. Yeah. Okay. All right. I can't think of any other vital information for your everyday life. I don't know if you guys know that reference from my Get all that with Lori Beth Denberg. Let me check here really quick. Okay, you guys are looking good. Okay. All right. So let me see. So exam 1 was due last night at midnight. And so with that, today we're going to continue chapter 1 on graphs and functions with section 1.4, a library of functions. Give me just a moment. I'm going to grab something. Just give me just a moment. Yeah, I've been talking about this stuff since like this morning, and then my mouth just got really dry, so I said, let me get something to drink. Okay, so with the library of functions, with this concept or this topic, what it is that we're going to start to explore some more sophisticated ways to graph functions. So far, ways that we've graphed functions. One, we plot points. So we choose several values of x, find the corresponding y, and plot the order pair. Sometimes we'll use our graphing utility, like our graphing calculator, to look at the graph where we hit the y equals. I know I've also suggested maybe either using Desmos.com. I know students like to use Desmos or GeoGebra. Right. So with the library of functions, we're going to start to lay the foundation for, or the foundational framework for graphing different functions. And so first we're going to explore a collection of different functions. A few objectives here. One, we like to define linear functions. Two, we like to discuss important properties of functions. Three, we like to graph square root and cube root functions. Four, we like to evaluate and graph piecewise functions. Five, we like to graph basic functions. And six, we like to find the average rate of change of a function. Okay. And so then also with this section, it's a rather long section. So we'll do the best we can to get through as many examples together today during class. But again, whatever we don't do together, I do expect you to like use my pre-recorded lectures, because those pre-recorded lectures is the same thing I would say live, it's just pre-recorded. And then so on Wednesday, we'll have an option. We can either continue with this live presentation, or we can go through as many homework questions together as we can regarding this section, right? So on Wednesday, we'll have a choice. That is refreshing. Okay. Energy's okay for right now. I'm a little bit sleepy, but not too sleepy. Not like, sometimes I'm just like barely keeping my head off the table. All right. So the first function that we introduce is our linear functions. So let m and b be real numbers. The function f of x equals mx plus b is called a linear function, right? So we've seen that one, and we've seen it described as the y equals mx plus b. So we've seen it as y equals mx plus b. Let's change that color. Right. And so, we'll be using the f of x and the y interchangeably. If m is 0, the function f of x equals b is called a constant function. So if our slope is 0, then we have a constant function, which is a flat horizontal line through y equals whatever that number is. And then if our slope is 1 and the y-intercept is 0, the resulting function is called the identity function. That's like y equals x. So that's a diagonal line with a slope of 1 passing through the origin. Okay. So the graph of a linear function is a non-vertical line with slope m and y-intercept b. So on this left image, we have a positive slope. Notice the slope is greater than 0. So as we trace the image from the left to the right, notice the graph rises, it goes up. So because it has a positive slope, as we trace it from the left to the right, the graph rises. With the second image, as we trace it from the left to the right, the graph falls. It has a negative slope. Okay. I'll check attendance for the latecomers in just about 4 minutes for anybody that's running late. I will say that in my last class, I had like 2 students that got in there after my second wave, and we were just about to leave, and he sent me an email, and it caught my attention, and I realized that they were in my waiting room. And I was like, okay, well, I went on and let them in. Yeah, I think I went on to give him credit. I was like, you guys got lucky, because after that second wave, you know, sometimes, you know, you're lucky if I look at the waiting room. Okay. And so then here we have on the left, we have a constant function, right? So that's where our slope is 0, and it's a flat horizontal line through y equals whatever that number is. Okay. And then, so again, this is the first one is the constant function. The second one is the identity function. That's like y equals x with the slope of 1 to the origin. This, that. I don't know how I can. We can work with this. Now, if I could leave it like this, that would be great. Or if I can get this to change. Can I get this to move? No, that's okay. All right, let's keep going. Yeah, they keep changing. That's so, it's like, it gives me a different image like each time, and I'm trying to get it to be consistent. So here we're asked to write a linear function g for which g of 1 is 4 and g of negative 3 is negative 2. Okay. All right, so they gave us that when x is 1, the corresponding y is 4. So when x is 1, the corresponding y is 4. No, I didn't move you over there. Let's put you back. Okay. And then when x is negative 3, the corresponding y is negative 2. Right. So then here, whenever I'm given ordered pairs like this, I personally like to just automatically label them. I'll go x1, y1, x2, y2. Okay. And we're asked to write a linear function g that passes through these 2 points. So then that means we're going to use, you can call it the slope intercept, which is y equals mx plus b. But we just saw it a moment ago introduced as f of x equals mx plus b. Okay. And so since we have ordered pairs, let's start off by finding the slope between these 2 points. So the slope formula is going to be the rise over the run, which is changing y over changing x. So that's going to be y2 minus y1 over x2 minus x1. And again, this is our slope. So I don't know if you remember when we were talking about lines before. Whenever we're working with lines, it's a good idea to have 3 equations ready to go. I'll go ahead and just put the third equation here. That's the point slope. Y minus y1 equals m times x minus x1. So whenever we're working with the lines, it's a good idea to have these 3 equations on deck. I'm just going to rearrange this stuff. Let's undo. Let's try that again. So our slope intercept, which is a y equals mx plus b, our slope formula, and our point slope formula. And I'm gonna just kind of leave this off to the side as a reference. But yeah, whenever we're working with lines, it's a good idea to have these 3 ready to go. Matter of fact, I'm being a little bit indecisive, and I am going to do the following. So let's go like this. We got this guy, this guy, this guy. I'm actually gonna put that there. Put this like here. That's okay. And then I'm just trying a different confirmation because again, I just really want this to be a reference. I don't want to take it up a whole bunch of space, right? Okay, so working with lines, we're gonna work with those three. Let's try this instead. I'm just trying to something to separate them, paste. That looks a little bit better. All right, so we got those three functions ready to go. Okay, so let's start by finding the slope between our points. All right, so again, slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right. So notice I use my slope formula, but I replace each component with a blank set of parentheses. Then I'm going to put the corresponding components in the blank parentheses. Again, the blank parentheses helps us to keep track of the signs, so we're less likely to make a mistake. Let me finish this one out, then I'll check my attendance. So my y2 is -2, my y1 is 4, my x2 is -3, and my x1 is 1. Okay. So then we get, what is this? -6 over -4, which is a +3/2. Okay. So that's the slope that we found. I'll continue working here. So now we could use the point slope because we have a point and a slope. I'm a fan of using the slope-intercept formula. So the y equals mx plus b. So we're going to say our f of x. No. So I'm still using y equals mx plus b. So now my m is 3/2. My x, I'm going to use the first point. I feel like the first point is easier to work with than the second. So my x is going to be a 1. We don't know the y-intercept. And my y is 4. All right. So then if we solve, b is going to be equal to 4 minus 3/2 is 5/2. Okay. So we have our slope, we have our y-intercept, so then we can just plug that into y equals mx plus b. So we got this f of x equals 3/2 x plus 5/2. Okay. Okay, that looks decent. Right. Oh, and then also it's a good idea to check to make sure that this actually works. Right. So we'll just write it here. We'll call it check. If we do f of 1, that's going to be 3/2 times 1 plus 5/2. That's going to be 8/2, which is 4. So that checks out. So the first one checks out. And then if we do f of -3, that's going to be 3/2 times -3 plus 5/2. Then that's going to be -9/2 plus 5/2, which is -4/2, which is -2. So that checks out as well. Okay. So, hopefully we're all aboard, and we're not all aboard. Hopefully this is clear. I think we have a type version of what we just experienced. So they found a slope similar to the way that we did. They got the same slope. Then they use the point slope form. Y minus y1 equals m times x minus x1. Right, but they got the same conclusion. Graphed it, showed that it all matched up. Okay. Let me check on you all in Zoom to see if because I know it's like at least one student I'm looking for, but he's MIA. And let me check the chat. Chat looks good as well. Okay, guys. All right, let's keep going. So again, if anything is not clear, feel free to unmute yourself to get my attention or type it in the chat and we can talk about it. So this next concept is regarding what do we mean by increasing, decreasing, and constant functions. Let f be a function and let x1 and x2 be any two numbers in an open interval AB contained in the domain of F, the symbols A and B may represent real numbers, negative infinity or positive infinity. Then we have the following to be true. So we say that F is an increasing function on an open interval AB if whenever x1 is less than x2, that implies f of x1 is also less than f of x2, right? In other words, the way we're going to see it, usually we discuss increasing, decreasing, and constant by looking at the graph. And so then as we trace the graph from the left to the right, the function is increasing, all right? So as we trace it left to right, the function goes up, okay? So if this is how we describe increasing, then this is how we describe what do we mean by decreasing function. F is a decreasing function on an open interval AB if whenever x1 is less than x2, that implies that f of x1 is greater than f of x2, right? So in other words, as we trace the graph from the left to the right, the image is going to fall. That's what we mean by a decreasing function. It's similar to like negative slope, but now we're incorporating curves. So this is like an extension of the slope discussion, just with curves. Okay. We talked about increasing, decreasing, and then we can also explore what do we mean by a constant function. So f is constant on an open interval AB if whenever we have x1 is less than x2, that implies f of x1 is equal to f of x2. Pictorially, that's going to show up as a flat horizontal line over that interval. All right. And I still got another class after you all. Actually, I got 2 more classes after you all. Okay, let's keep going. Okay. Like my thing is, I mean, I get the thing about being live. Let me just stop complaining. Let me just stop complaining. Like, I mean, I totally would do it different. I would just do it different, but you know. And I mean, honestly, I could shift these, but I do want to kind of like offer a presentation. Like I could easily just rely on my recordings and just say, hey, I'm just here for questions, all right? I know some of my colleagues do that, and it is a lot easier. It's a lot more feasible on my end as far as having energy. Because like by the time I get to you all and my next class is after lunch. I've been talking since like 9 in the morning, like, you know, and it's kind of repetitive, right? Because I'm saying the same thing. And so if I had a recording and just made myself available for questions, then it would be easier for me. Either way, I can say it once, you know, and then just practice, right? Instead of, because like if it's dynamic, if it's like homework questions and stuff like that, then it changes and it's not so repetitive for me. Versus with this, but I'm doing it this way because I would like you guys to have some kind of a live presentation. I'm just doing it just because, but it's not really necessary. Again, all the stuff that I'm doing here is already in my pre-recorded lecture. But let's keep going. Yeah. Okay. So from here, okay. So tracking the behavior of a function from the graph of G, find the intervals over which G is increasing, decreasing, or constant, right? So here's an example where we explore what do we mean, like how do we show that it's increasing, decreasing? So first thing I want to kind of bring to your attention, let's go like this color, and let's go like this. That's decent. Let's go here. Like that looks good. Let's go style. About this thickness and that's too thick. That's good. All right. So where it's changing, copy from increasing, decreasing, or constant. Undo, paste. That's how I'm marking these, right? And so what these vertical bars, what they do, they break the graph up into like 3 regions. We have this like region A here. We have this region B in the center, and this region C to the right. So initially, as we trace the graph from the left to the right, initially it's rising. The graph is increasing, right? And so then we can capture that by saying, and I'm going to abbreviate, instead of writing out the word increasing, I'm going to abbreviate it with like an up arrow. We're saying the graph is increasing on the interval. Now, what interval does that cover? what portion of the domain on the x-axis, right? So the far left will be what? Negative infinity up to when x is what? -2. Whenever we're doing increasing, decreasing, and constant, we typically use parentheses for all our results. So we're saying it's increasing as x goes from negative infinity to -2. Okay. And that's like, I'll notify it by saying, hey, we're talking about in region A. In region B, right, we're saying that the graph is what? Constant, it's flat, as x goes from -2 to 3. Right, that just means constant. And then for region C, we're saying our function is decreasing because as we trace it left to right, it falls as x goes from 3 to infinity. And that's how we can capture increasing, decreasing, and constant in this context. Okay. So it's increasing on that region A, is constant on region B, is decreasing on region C. Let's put this thing. Increasing, constant, and then decreasing.
Okay. On the graph, if it gave us, as far as region A, if it gave us on an exact graph to where it stopped, if it didn't have the arrow and it stopped at a certain point, and the third quadrant, we have to put that instead of infinity.
Oh, yeah, I would have to see an example, but that would essentially be a yes, as long as the graph stops. But we do typically use parentheses for this discussion. But something like that would be best if we can see an example. But from sounds like what you described, it would be a yes. Okay. All right. So then, what do we mean by like a relative maximum and a relative minimum? If A is in the domain of a function f, we say that the value f of A is a relative minimum of f. If there's an interval x1, x2 containing A, such that f of A is less than or equal to f of x for every x in the interval x1, x2, and it's something similar for the max, right? So the long story short, what we mean by relative min and relative max, we typically discuss these in a pictorial representation. And so relative max, we're talking about the peaks of the mountain or the hill, and then relative minimum or the bottom of the valleys. All right, so that's generally how we discuss it. And so like this would be our f of A that's less than all nearby f of x, right? This would be our f of A that's less than all nearby f of x, right? All the nearby y values or whatever. That's the lowest point in that region. Here's the lowest point in this region, the highest point in that region, so on and so on, right? So relative max and relative min are just discussing these peaks and valleys. Okay, and we'll see some examples exploring these. So then we have this, so we just saw increasing, decreasing, and constant. We saw relative max and relative min. A relative max typically occurs when a function goes from where? Increasing to decreasing. So then there we typically have a relative max. Relative min occurs where a function goes from decreasing to increasing, right? So that's actually one of the things that we do in calculus. Identifying local max or local min, we got to show that the graph is changing from increasing to decreasing or vice versa, right? So we saw increasing, decreasing, and constant. We saw relative max and min. So now we have this concept, these concepts of what do we mean by even function, odd function, or neither, right? An even function, we say a function f is called an even function if for each x in the domain of f, negative x is also in the domain of f, and we have that f of negative x equals f of x, okay? Sorry. The other thing is, I just realized I don't think I've eaten anything. I'm trying to think. I don't think I ate anything, so that's probably another theory. It's so weird because, like, if I eat something that makes me sleepy, if I don't eat anything, then I don't have any energy. I'm like, this hour is just tough for me because, like, I'm usually like out cold, right? So another piece of information with even functions is the graph of an even function is symmetric with respect to the y-axis, right? So whenever we identify a function as even, we have y-axis symmetry, right? So that's a concept using symmetry to graph functions. If we have y-axis symmetry, whenever we have any point x comma y, we also have the corresponding point negative x comma y, right? So if you were to, you know, replicate it or translate it across the y-axis, you know, whenever you get a point on the left, you automatically get a point on the right. Once you identify that the graph is even or has y-axis symmetry. Hopefully, we'll get to see that in action when we start graphing. Okay, so now if we could talk about a function being even, we can also discuss what do we mean by a function being odd. A function f is an odd function if for each x in the domain of f, negative x is also in the domain of f, and we have f of negative x equals negative times f of x, right? For even is f of negative x equals the original. For odd, it's f of negative x equals a negative times the original. The graph of an odd function is symmetric with respect to the origin. So like origin symmetry, the way I visualize it, if you cut the image along the x-axis, like just cut it along the x-axis, and if you put your thumb on the origin and you rotate the top half 180 degrees, it should match up with the bottom half. So I consider origin symmetry like rotational symmetry. Another way to kind of visualize origin symmetry, whenever we have x comma y, we also have negative x comma negative y. So you'll have these like points that are kind of like always equidistant and symmetric about the origin. And it's like they kind of like dance, or they're always centered around the origin, right? And we'll see this momentarily. Okay. Let's see something. This. Okay. Okay. Done. Okay. All right. So we saw an example. So whenever we see even, odd, or neither, when it refers to functions, it's really a discussion on the symmetry. It's really a discussion about symmetry. So in this example, we're asked to determine whether each function is even, odd, or neither. I think we might have one more example after this. With my other classes, we stop.
Morehouse?
Is there something else? So I might do one more after this one. It just depends. Okay. Even, odd, or neither. All right. So to do a test for even, odd, or neither, we replace x with negative x, we simplify, and we interpret the results. So first we're going to replace each x with a blank parenthesis. So we got g of x equals x cubed minus 4x, okay? And we're replacing each x with negative x. Okay. So then if we simplify, negative x times negative x times negative x, we have an odd number of negatives, so that ultimately is going to be negative. For the second term, double negative is positive, so that becomes plus 4x. We ask ourselves, is this the original? No, it's not the original. So then let's try factoring out a -1 from all the terms. If we factor out a -1, we're going to be left with x cubed minus 4x, right? Okay. Notice that this is negative times the original, right? So we started with g of negative x. We finished with negative times the original. That's the definition of a function being odd. So that's how we show a function is odd. So if we were to look at that image, that would have origin symmetry. Okay. I'll go ahead and do B here.
And for the first line of A, that negative x disappeared because it multiplied with the negative sign in front before, right?
You're talking about these guys?
Yeah, at the top, like the first line. Yeah, that's the cancel out rule, right?
Yeah, double negative. A -4 times a negative x is a positive. That's a double negative. Yeah. Okay, so something similar for B. We want to do a test for even, odd, or neither. So we replace each x with a negative x, simplify, and interpret. So then we have f of x equals x squared plus 5. Okay. So we're replacing each x with negative x. Okay. So then if we simplify, now, see, now my mind is wondering. It's like every time I say K, I'm thinking of Mr. Mackey from South Park. Okay, so we replace the x with negative x. Okay. Nope, no, don't do that. That's bad. Okay. Man, I'm so sleepy. I get so like loopy and sleepy when I get so loopy when I get sleepy, and I start having more fun. It just be funny stuff. These images, I'd be laughing. Okay, let's keep going. So if we got negative x squared, right? We have negative x times negative x. So double negative is positive. We have an even number of negatives, so that's going to be a positive x squared plus 5. Is this the original? Yes. All right, this is the original. So now that means we started with f of negative x and we finished with the original. That's the definition of a function being even. Paste. Just like that. All right. Let's create some space so that we can work on C. So what I'm going to do, I'm going to shrink this stuff down just a little bit, just so we can make some space for C. Let me shrink it down just a little bit more. Okay, so, I know it's a little bit small, but I think you can follow it. So then let's work on C. I'm gonna work on C here, and I'll adjust it a little bit later. So again, we're replacing each x with a negative. So first we're doing the blank parentheses. Okay. And then we're plugging in a negative x. All right, so we introduced the negative x because that's how we do a test for even, odd, or neither. So in that first term, we have an odd number of negatives being multiplied, so that result's going to stay negative. The second one, we have an even number of negatives, so that's going to become positive. We ask ourselves, is this the original? No. So then we try factoring out a -1 from all the terms. But even if we factor out a -1, we don't get negative times the original. So this is an example of something that's neither. It's neither even nor odd. Paste. Nice. Okay. And I'm just going to rearrange this. That looks good. That looks good. And I'm just trying to get it to a decent size. We can go to about there. I can actually expand this some. About there. All right, that's decent. And then let's expand this a little bit as well. That's decent. Cool beans. Nice. Ain't gonna lie, I really enjoy writing on this device. Like, this is so much better than standing at a board or being in front of a group, And I kind of be kind of easy on you guys. Like, I don't try to like force you to have your video on. I don't hound you guys. Like, in my eyes, in my heart, like I'm like, okay, you guys are adults. I know you're just like leaving home, but at some point you got to become responsible for yourself. Like, you got to start, taking charge of your life, right? And if something bad happens in your life, you have to take ownership. You have to be responsible for yourself. But if something good, you can revel in that glory, right? So I just try to be easy. It's like, look, as long as they have access to what they need, they're adults. If they're going to make a decision to procrastinate or whatever, they got to deal with that, right? But on the flip side, if they decide to get ahead and finish early and position themselves for success, then that's on them as well. I just try to make myself available, and I try to encourage you all to take charge of your life. You're adults, right? So you have to start deciding for yourself. at some point you got to start being treated like an adult. I don't really believe, and that's just my personal style. I don't like micromanaging and people telling me what to do. That's a quick way to piss me off. And then it's like sometimes subconsciously I do it out of spite. I like, do things to spite, out of spite or whatever. But that's me being immature. Okay, so let me see here. Give me just a moment. This thing is kind of on the tantrum a little bit. Okay. We have a solid 4 minutes. Let me see. I think I'm just going to stop here because I kind of need to get ready for my next class. Are there any burning questions? Do you guys have any burning questions for me? And then 3 minutes isn't really enough time to talk about that thing.
I'm sorry. Can you view the slide of the even and odd one more time, like the formula or the rules?
Yeah. So with all of this, so keep in mind that everything that I'm writing on the screen, like all of this stuff, you actually have a copy of it. So that's exactly what I was about to do. Let me go ahead and make a copy of this available for you all. All right. So if I go here, I go to share, I send it to Box. So let me just make it available. This is the fall 23. This is traditional. College Algebra 1, updated daily, right? And so here, when I hit send the box, when this bar finishes loading, all the stuff that you saw me writing, and I'll go ahead and pull up the one that you were looking at. Okay, come on. Okay, well, I gotta wait for this to go away. But once this bar finishes loading, you'll receive a copy of everything that you saw me writing. It's basically a PDF. Okay, so yeah, you can access it, and like if you go to like Blackboard, when you're reviewing your notes, you basically have a copy of all of this stuff. And then, so when you're reviewing your notes later, you can use it as a reference or use it directly or whatever. So again, we did what we could together. We made it to about slide 20. What's a good idea is you can take this, the rest of the slides are there, but they're not worked out. So then maybe you can like read through the examples, and it's a good idea to try to work these out yourself to see, okay, can you arrive to the correct solution on your own? Like this one isn't worked out, but then I think we have okay, I think we're okay. We have the type solution on the next slide or whatever, but but yeah, I can't think of anything else. So are there any other burning questions before we go our separate ways? Going once, going twice, forever, hold your peas and rice. Okay. So with that, you do have a copy. We did finish exam 1. It was due last night at midnight. If you want to go back, if you want to improve your overall grade, I would encourage you to go back and basically redo your assignments and prioritize your exams where you're gonna get the most bang for your buck. If you made below a 90 on any assignment, you can go back. The homework, be careful because that can be a lot of work for like no points. If you're trying to see like your grade grow, prioritize your exams. That's going to be the bulk of your grade. Okay. So if there aren't any burning questions, we're going to go ahead and end the session here. We'll meet again on Wednesday, same time, same place. We'll end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.
Professor?
Yes. Can you hear me? Yelly Oxenfree, can you hear me? Can you hear me? Hello, hello.
Yes, sir, I can hear you.
Yeah, I can't hear you. You there? You might have to type it in the chat. I know somebody had a question, but I don't hear anything. Going once, going twice. Hello, hello. Let's see if we go like this. Can you hear me? All right. Oh, okay, there it is. Let me see. Okay. For the lab, okay, so questions about the lab, I have to redirect you for the lab. Do we attend any day or every day? So with that, you'd have to consult Dr. Lamar. So basically, those are her rules, so that's something completely separate from what I do. So you'd have to contact her, and then whatever she says, that's the recommendation. Okay. All right, gentlemen. All right. So if there are any other burning questions, we're going to end the session here. Let me see. Are we allowed to retake exams? Yeah. Is he from this class or the next one? Yeah, you can retake your exams. As long as it allows you to do it, you should be able to do it. Yeah, he's for the next class. Okay. Any other burning questions going once, going twice?
No questions. Thank you, sir.
All right, take care. All right, gentlemen. So if that is all, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.